QES Consulting Group. Answers to tough marketing and technical problems. Identifying tough problems. Simple problems are a new app, another hardware interface, or the next generation technology. They capture existing market share by making something a little better. We can help there, but so can a lot of other good people out there. And then there are the really tough problems, like creating new markets and the technology to support them. This is what we look at, developing new markets and their technology. Market technologies are simple looking backwards, but not looking forward. Developing new market and technology pathways seems daunting. Mark Zuckerberg and others struggled with social networking for years before incorporating relationship status and making it a revenue generator. Bloodletting was the medical standard for years before Pasteur discovered microbes. And Einstein's 1905 discoveries that velocity alters space-time and that electron energies are quantized led to quantum theory and our 20th century technological revolution. Each a simple step that changed the world, looking backwards, but completely unknown and complex before their discovery. So how does the unknown and complex become simple? How does the difficult become easy? Things become easy when they fit into existing science and economic models. Looking forward, they require leaps in logic, and predicting which will be successful seems even more difficult. But existing science and economic models do offer a degree of predictability. Machine learning routines identify relevant demographic factors. Insurance companies optimize risk-profit ratios from actuarial studies. Weather models do accurately predict the weather, and Nash's equilibrium can be used to optimize profit margins. So how does looking forward become easy? Years ago, when stores had fountains, a Walgreens buyer purchased several million eggs at a penny apiece. Excited at his good fortune, he rushed to tell his boss. But to his amazement, his boss became upset. Walgreens had no way to sell eggs. Faced with the prospect of a big loss, the boss went to his boss, and so on. The problem finally reached the CEO, who called in a marketing consultant he knew. A day later, the consultant was back with a solution and a bill for $10,000. The consultant simply held up one egg in one hand, two in the other, and said, "One egg or two." He had Walgreens change the price of their malts to include 5 cents more for each egg. Walgreens was very happy with their 500% profit margin and quickly paid the consultant. What made the consultant worth $10,000 a day and cheap at the price? Vision that saw outside the box of the problem. Problems are just steps towards solutions. Knowledge that the first step to closing a deal is to get a pen into the customer's hand. Asking someone if they want something will almost always get a negative response, but asking them to make a choice closes the deal. Action, and Steve Jobs explained it perfectly in his 10 Steps to Success lecture. Telling people how good milk was didn't help sales at all, but showing someone eating cookies and asking if they got milk did. Can predictability models be expanded to include vision, knowledge, and action? Of course. The components that make predictability models predictable are also the basis of our thought processes and our models of physical reality. Wittgenstein said, "The world is the sum total of atomic facts," meaning that it is not possible for something to exist at our level that doesn't originate at the particle level. For instance, particles have 5 energies: mass, charge, magnetism, spin, density, and we correspondingly experience reality with 5 senses that function in terms of them. Wittgenstein also said, we think in terms of the words we know, words that are attributes of our senses, and their corresponding realms. And even more interesting is the fact that these energy forms all exist and transform by the same set of equations, the same equations that make predictability models work. These equations may seem complex the first time, but they do simplify things. The equations are called the e to the x equations, and they have 4 forms. E to the x describes energy transforms, from radioactive decays to social and political changes. E to the minus ix describes stable states, from particles and atoms to demographic and actuarial categories. E to the IX describes their excited states, from the quantum states in atoms to people's passing interests. And E to the S over K describes probability outcomes, from the light spectra of atoms to Nash's equilibrium. They work in all these situations because they all have a common behavior that matches them to physical reality. They show what happens when something is changed, added, or removed. They are a reality calculus that analyzes and predicts what occurs when circumstances change. And we can do this for you in terms of potential new markets and technology, or we can show you how to do it on your own. Technology hasn't fully caught up with Einstein, and there's a reason for it. A little problem called Heisenberg's uncertainty says measuring something introduces error. Measuring a particle's position and velocity with a light wave changes it, so trying to predict the particle's behavior by looking at it makes it unpredictable. This limits progress in quantum theory and things like super high-speed computers. But Heisenberg's uncertainty also says there is an uncertainty to it. Sometimes it is predictable. We know this to be true because the universe keeps recreating itself in a predictable way. And Einstein's math works only if predictability originates at the most fundamental level. Yukawa actually used the size of Heisenberg's uncertainty to predict pions, the particle responsible for nuclear bonds, which is why all the universe's nuclear bonds are identical. Heisenberg's uncertainty has a certainty that makes it predictable. The uncertainty is limited in size, and its boundaries are the reason statistics works. Statistical systems have limited ranges that limit the size of their e to the s over k statistics. Oil and chemical companies have been using this for years to refine chemicals they want to bring to market. And what it means technically is that the e to the x equations are factors of each other. So if we can figure one out, we can predict the others. We call this entropic calculus. S measures the size of a situation's uncertainties, the demographic size of the behavior box, so to speak, and the calculus aspect of e to the x predicts what will occur when things are changed. Entropic calculus gives us an edge in figuring out marketing and technical strategies because it allows us to see what will happen if we go outside the behavior box. Some of our other skills include electrical, mechanical, software, and chemical engineering, writing, editing, graphics, mathematics, statistics, and presentations, detailed investigations into different fields, such as autistic job ventures, quantum energy systems, and a nuclear gravitational electrodynamic framework. Our team includes Matt Gray, Polly Adams, and William Gray. And our rate is competitive. Thank you.